Okay, the question is limit from -2 to 2, and this is 5 over x squared plus 4 whole square over here. And the substitution is x equal to 2 tan theta. Now you must ask yourself that why do we have to use this substitution over here? Thoda sa brainstorming can help you remember the techniques for the integration. So you see that there is x squared plus 4, and then there is a square. Because of this square, you cannot keep it in the denominator. You have to move it to the numerator. When you move that to the numerator, so then you will have something like this. Let me just, like, this is just brainstorming session with you. X squared plus 4 raised to power minus 2. Now, can you integrate this directly?
No,
Why not?
because it's x squared, it's not linear equation.
Exactly, mashallah, mashallah. Very good, beta. Because inside the brackets, the expression that is non-linear. So we can't integrate this directly. That is why we have been given this substitution over here, okay? So please remember these little things, okay? So now let's start substituting this. So I'll just naming it as I, okay? I'm not writing the limits right now. So I have here, this is going to be 4 tan square theta plus 4, and then there is a square. Now the people who are really good at the trigonometrical identities, this is going to be a mouth-watering kind of a thing for them, because when they look at this thing, what should be coming in their mind? Yes, anyone who is good at, yeah?
4 secant square.
Yeah, exactly. Because you know that you can take a 4 common from here, and 1 plus tan square is going to result as secant square. Okay, that's great. Now, we can't do anything about this 5, so I'm just going to write this outside here, this 5, okay? Now, it's a turn of this dx. So you differentiate this. This is going to be dx by d theta. So this is 2 secant square theta. Yes. So this dx that we had here can be easily substituted with 2 secant square theta d theta. Okay. So I have here 2 secant square theta, and then I have d theta over here. So we should learn to change these limits, because you might have a question where you have to write this in a form in terms of theta, and you have to give these limits as well. So you must know how to change these limits. So when you have your x as, when your x is -2, so your 2 tan theta, that is equal to -2, and your tan theta is going to be -1, and theta is going to be, I will write it as minus pi by 4, okay? And when your x is 2, so this 2 tan theta will be equal to 2, and your tan theta is 1, and your theta is going to be pi by 4. You must know these values by heart, okay? So this is minus pi by 4, and this is pi by 4. Okay, so as you guys realize, if you take 4 common, I'm just going to save some space here. I'm going to write that what is going to be written instead of this here. So this, let me just write it over here. Okay, this will become 4 into tan square theta plus 1. And this can be written as, I'm putting a star over here, and this working is being done here. Okay, so this is going to be 4 secant square theta. And then you see there's a square on it. So this, when you square all of this, so what will happen to it? This will become secant 16 secant to the power 4 theta. So in the next step, I will be writing it as 5 limit from minus pi by 4 to pi by 4. This is 2 secant square theta divided by 16 secant raised to power 4 theta. Okay, and now we can cancel them out. The secant square theta cancel and the 2 is left here. And we also have this 2 1s are, 2 8s are. So now we have 5 over 8 limit from minus pi by 4 to pi by 4, and this is going to be cos square theta. Now again, you cannot integrate this cos square theta. So you must recall that 2 cos square theta is 1 plus cos 2 theta. Okay? So if you take this 2 over here, so this would become 5 over 8 into 1 over 2. And this is 1 plus cos 2 theta d theta. I'm just going to leave it up to this and you can complete it yourself. Do you have any questions here? Yes? No question? Just remember that this is a P3 question and you see that you have to do so many things to reach to the final answer. You see that there is a lot of algebra, there's a lot of a lot about the trigonometrical identities and then the differentiation and even the trigonometrical equations when you are finding these values over here. Okay, so you see that this nearly all of your pure mathematics is being tested over here.